Suppose that a, b, c are integers such that a root 2 plus b equals c root 3. By squaring both sides of the equation, show that a equals b equals c equals 0. Okay, this should be hopefully pretty straightforward. And this is just something that, you know, I don't want to say should be familiar, but these types of ideas that when you're adding together irrational numbers that are, or when you're adding together square roots of things that are not perfect squares, you can't really make things work out nicely in some sense. Anyway, I'm just going to follow what the question has asked here. So we're going to suppose that this is true. A, B, and C are integers. If we square both sides, what do we get? We get 2a squared plus 2 root 2ab plus b squared is equal to 3c squared. Okay, so if we rearrange this, we get the following. A, B, and C are integers, so that's an integer. We could, in fact, why don't we divide both sides by something here? So we have root 2 is equal to 3c squared minus 2a squared minus b squared over 2ab. Okay, so this is a contradiction because this is irrational, but the way it's written like this, it looks like a rational number. The only way we can avoid this contradiction is if a times b is equal to 0, meaning we're not actually allowed to divide by ab. So this says that a is equal to 0, or b is equal to 0, or both. Okay, well, why don't we work this out case by case? Suppose a is equal to 0. Then we have b is equal to c times root 3. And again, we have a contradiction because if we divide by c, then we have a rational number is equal to an irrational number. So assuming a equals 0 implies that both b and c are equal to 0. Okay, what about the other case from before? B is equal to 0. This says that a root 2 is equal to c root 3. And this says that a over c is equal to root 3 over 2. There's a follow-up in the question that says that, well, let's write it another way. Hold on. Before I read exactly what the follow-up in the question is. It says c over a is equal to the root 2 over root 3. So there's a follow-up in the question in parentheses. It says we can assume that root 2, root 3, and root 2 over 3 are irrational. And so again, the only way that this is possible is if we're not allowed to divide by a, meaning that a is equal to 0. Okay, so, and of course, if a is equal to 0, then clearly from the right-hand side, c is equal to 0. So if we combine cases 1 and 2, we have that a, b, and c are all equal to 0. Yeah, so nice little problem. Really just being familiar with irrational numbers and you know, the knowing that something is irrational and then representing it like as a rational number means at some point we've done something along the way which is not allowed, and the only thing we weren't really allowed to do here is divide by a times b if it's 0. Yeah, nice little problem. If I have more to say, I'll put it in the description. Thanks for watching.